DFSS Black Belt projects focus on designing or redesigning processes, products to achieve high quality and customer satisfaction. Projects should be aligned with business goals and have measurable impact. Key requirements include clear problem statement and objectives, availability of data for analysis, support from leadership and stakeholders, cross-functional team involvement, potential for significant financial or operational improvement. Ensures the Black Belt can apply DFSS tools effectively to drive results. DFSS Black Belt projects focus on designing new processes, products, services, or systems, unlike DMAIC, which improves existing ones. This chapter covers what qualifies as a DFSS Black Belt project, project criteria and expected deliverables, expected results and impact, tools required for DFSS projects, how to document and present the project, common pitfalls and tips to avoid them. Goal is to understand requirements clearly and ensure a successful DFSS project. Here are short speaker notes for what is a DFSS Black Belt project. A DFSS project either designs something brand new or redesigns from scratch when existing solutions fail. Examples: new mobile app feature, redesigning hospital patient flow, new assembly process for a product, new claims processing workflow, customer onboarding model. Projects should be complex enough to require advanced tools such as QFD, DO, regression, optimization, FMEA, tolerance design, MCDA, POO matrix. Goal: deliver innovative, high-quality solutions *** using DFSS methodology. A valid DFSS Black Belt project must meet key requirements. The first is a strong link between voice of customer or VOC and CTQs. The project should start with a VOC analysis, which can include customer interviews, internal VOC data, market research, Kano analysis, affinity grouping. Finally, you need to show how VOC insights are converted into CTQs, the measurable characteristics that define quality. This is covered in Chapter 8.1 of the DFSS Black Belt requirements. Requirement 2 is the use of QFD or Quality Function Deployment. QFD links what customers want to what the design must deliver, and a house of quality is mandatory in DFSS projects. Requirement 3 is demonstrating concept generation techniques. You need to show that multiple design options were explored using tools like brainstorming outputs, TRIZ for contradiction resolution, mind maps, concept sketches. The key is to show variety in design concepts, not just a single solution. Requirement 4 is structured concept selection. Use tools like POO matrix, MCDA scoring, risk-based selection. The goal is to compare multiple options and clearly justify the chosen design. Requirement 5 is Y equals FX modeling, which ensures the design is data-driven. This involves statistical techniques like regression, correlation, ANOVA, DO results. These analyses show that the project decisions are based on evidence, not assumptions. Requirement 6 is DO or optimization, which is mandatory for Black Belt projects. This includes factorial design, response surface optimization, simulation, parameter design. This step demonstrates how the design was optimized for best performance. Requirement 7 is risk analysis using FMEA. Both design FMEA and process FMEA should be included. You need to show identification of failure modes, RPN risk priority number ratings, recommended corrective actions. Requirement 8 is prototype or pilot testing. The design should go through simulation, prototype build, pilot execution, small-scale rollout. Evidence can include mini-tab pilot data, Excel monitoring sheets, or charts showing stability. Requirement 9 is verification with statistical evidence, which is mandatory. You need to show hypothesis tests, capability comparisons, control charts. Validation of predicted improvements. Requirement 10 is the sustainability plan. The project must include control plan, SOPs, training documents, audit plan, dashboard monitoring. This ensures the new design continues to perform effectively. In addition, a successful DFSS Black Belt project must demonstrate innovation, new design, system, or workflow, advanced analytics, strong customer alignment, risk mitigation, practical implementation, quantified results. Typical DFSS Black Belt project deliverables are divided by phase. Defined phase deliverables include VOC statements, CTQ flowdown, SIPOC if applicable, DFSS project charter, business case. Measure phase deliverables include operational definitions, CTQ metrics, baseline capability, if an old process exists, QFD. Analyze phase deliverables include concept generation using TRIZ, brainstorming, or mind maps, PU matrix or other decision criteria, risk-benefit analysis. Design phase deliverables include DO results, regression modeling, optimization plots, design specifications and prototyping, DFMEA. Verify phase deliverables include control charts, capability results, pilot test results, SOPs, and control plan, training plan. Here are some DFSS Black Belt project examples across different industries. Manufacturing: design a new packaging material to reduce damage. Create a new assembly sequence for an electric motor. Healthcare: design a new patient triage model. Redesign the medication administration system. BPO: create a new customer onboarding workflow. Design a ticket prioritization algorithm. IT, software: design a recommendation engine for e-commerce. Create a low-latency API architecture. Banking insurance: design a fast-track loan approval system. Create a digital claim submission process. These examples show that DFSS projects can be applied in any industry to improve processes, designs, and customer experience. Success checklist for DFSS Black Belt projects. Ask yourself, have you used QFD? Have you generated at least 3 to 4 design alternatives? Have you used PU or MCDA for selection? Have you applied DO or regression analysis? Have you verified results with statistical evidence? Have you demonstrated pilot testing? Have you created a sustainability control plan? If the answer is yes to all, your project qualifies as a DFSS Black Belt project. Common mistakes to avoid: doing DMAIC instead of DMADV, skipping DO or optimization, considering only one design option, failing to convert VOC into CTQs, weak statistical validation, not performing pilot testing.